Billions and billions of galaxies. The universe is so vast, we can't even imagine what those numbers mean. But 14 billion years ago, none of it existed. Until the Big Bang.
The Big Bang is the origin of space and the origin of time itself.
We take a journey through space and time, from the beginning to the end of the universe itself. This is our world. Cities, forests, oceans, people. Everything in the universe is made from matter created in the first seconds of the Big Bang. Every star, every planet, every atom, every blade of grass, every drop of water.
Water is ancient. The hydrogen atoms in here were born moments after the Big Bang. Then came everything else.
The Big Bang is the defining event of our universe and everything in it. The secrets of our past, our present, and our future are locked inside this one moment in time. To unlock the secrets of the Big Bang, we have to travel outside of our own solar system and journey beyond even our own galaxy. As we travel into deep space, we're actually seeing into the past and getting closer to being able to witness the dawn of time itself. Passing the first infant galaxies and the first stars. We arrive back at the moment the universe began and face the biggest questions in all of science.
This is the holy grail of physics. We want to know why it banged. We want to know what banged. We want to know what was there before the bang.
To get the answers, we've built machines the size of cities to simulate conditions when the universe was created, and space telescopes to peer deep into our past.
We are getting close to answering the old 8 questions. Why are we here? Where did we come from? Does the universe, in fact, have a beginning or an end? And if so, what are they like? If we find the answer to that, it would be the ultimate triumph of human reason. We would know the mind of God.
The origin of the Big Bang is the greatest mystery of all time. And the more we learn, the deeper the mystery becomes.
We like to think that our universe is unique. However, now we're not so sure. Perhaps there is a multiverse of universes.
Another possibility is that our Big Bang is just one of many Big Bangs, but it may be one of just an infinite number of universes, and there may be other regions in that infinite number of universes where a Big Bang is just happening today.
But there's only one universe we're sure of, and understanding this one is hard enough. Since the late 1920s, everything we know about how our universe works has been turned upside down.
It's important to realize how much our picture of the universe has changed in the last century. At the beginning of the 20th century, the conventional wisdom in science was that the universe was static and eternal.
In 1929, that all changed. At the Mount Wilson Observatory above Los Angeles, astronomer Edwin Hubble discovered galaxies aren't stuck in one place. Not only are they moving, but they're flying away from Earth at incredible speeds. This was the first real evidence of the Big Bang.
All galaxies on average were moving away from us, and stranger still, those that were twice as far away were moving twice as fast. And those that were 3 times as far away were moving 3 times as fast, and so on. Everything was moving away from us.
It became known as Hubble's Law. His discovery is still the starting point for exploration of the Big Bang.
What Hubble convincingly demonstrated by seeing the motion of those galaxies is that the universe is expanding.
Theoretically, an expanding universe must have started from a single point. By measuring how fast the universe is expanding, astronomers calculated backwards and figured out when it burst into life.
People ask the question, how do you know that the universe is 13.7 billion years old? I mean, smarty pants, you weren't there 13.7 billion years ago. Well, when you watch television on videotape, you hit the stop button when you see an explosion, and you could run it backwards and see when it actually took place. The same thing takes place with cosmology. We can run the videotape backwards and then calculate when it all came from a cosmic explosion.
You don't have to be an astronomer to look back in time. If you gaze up at the night sky, you're seeing stars that are millions of light years away, meaning it took the light from those stars millions of years to get here. So, if you look far enough, you should be able to see the beginning of the universe. Named for the groundbreaking astronomer, the Hubble Space Telescope allows us to look deep into the universe, back in time, and closer to the moment of the Big Bang. But for scientists, winding back the clock to the Big Bang was only the first step.
When people first hear about the Big Bang Theory, they say, well, where did it take place? It took place over there, it took place over there. Where did it take place? Actually, it took place everywhere, because the universe itself was extremely small at that time.
These are only some of the most abstract and difficult concepts there are. So here's a mind bender. What came before the Big Bang?
The philosophers in ancient times used to say, how could something arise from nothing? And what's amazing to me is that the laws of physics allow that to happen. And it means that our whole universe, everything we see, everything that matters to us today, could have arisen out of precisely nothing.
It's one of the biggest hurdles to understanding the Big Bang. First, you have to buy into the premise that something was created out of nothing.
It's impossible to describe the moment of creation in human language. All we know is that from what may have been nothing, we go to a state of almost infinite density and infinite temperature and infinite violence.
Understanding how nothing turned into something may be the greatest mystery of our universe. But if you understand that, you start to understand the Big Bang, when time and space began, and a great big explosion created everything. At the dawn of time, the universe explodes into existence, from absolutely nothing into everything. But everything is actually a single point, infinitely small, unimaginably hot, a super dense speck of pure energy.
The Big Bang was so immense that it brought into existence all of the mass and all of the energy contained in all of the 400 billion galaxies we see in our universe in a region smaller than the size of a single atom. The entire observable universe was a millionth of a centimeter across at that time. Everything was compressed into an incredibly hot, dense region.
It's not even matter yet, just a point of raging energy. It was the beginning of the universe and everything in it.
Everything was simple. All the forces that we know about today were one and the same. The universe was amorphous. It had no structure.
In that instant of creation, all the laws of physics, the very forces that engineer our universe, began to take shape. The first force to emerge was gravity. The fate of the universe, its size, structure, and everything in it, was decided in that moment. Carlos Frank studies how gravity shaped the universe by creating artificial universes in this supercomputer. He gives each one a different amount of gravity. The first one he tried had too little, resulting in, well, nothing.
Gravity, it has shaped our universe. Or if gravity was weaker than it is, we would have a very boring universe in which everything would be flying apart so fast that there would be no galaxies forming.
Next, he programmed a universe with too much gravity.
If gravity was stronger than we think it is, again, we'll end up with a failed universe. Everything will end up in black holes. It has to be just so. It has to be just right.
Lucky for us, the Big Bang got it just right. The perfect amount of gravity. In the turmoil of forces after gravity emerged, still a fraction of a second after the Big Bang, a shock wave of energy erupted and expanded the universe in all directions at incredible speed.
All of space expanded by an unbelievably large factor in a fraction of a second. We think that in less than a millionth of a millionth of a millionth of a millionth of a second, space expanded by a factor bigger than a million, 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 million times.
And for the record, that's faster than the speed of light. But wait, doesn't that break one of the laws of physics?
Even school children know that, quote, you can't go faster than the speed of light. But actually there's a loophole there. You see, nothing can go faster than light. Nothing being empty space.
Don't worry, this idea gives even the best minds in science a headache.